Hi everyone, welcome back to the channel. In today's video, we are going to answer another very common React interview question. How do you optimize performance in a React application? This is a great question because React apps can become slow if we don't manage rendering properly. So let's go through some common techniques developers use to improve React performance. The first thing we try to do is avoid unnecessary re-renders. Sometimes components re-render even when nothing actually changed. To solve these, React gives us a few optimization tools. React.memo prevents a component from re-rendering if its props haven't changed. Now, the component only re-renders if name changes. This is useful for components that the same props often. useMemo. useMemo memoizes a computed value, so React doesn't recalculate it on every render. Now, the calculation only runs when data changes. This is helpful when we have expensive computations. useCallback. useCallback memoizes functions. This prevents a new function from being created on every render. It's especially useful when passing callbacks to memoized child components. Lazy loading components. Another way to improve performance is lazy loading. This means we load components only when they are needed. Instead of loading the entire application at once, React loads parts of the app on demand. This reduces the initial bundle size and improves load time. If we render very large lists, performance can drop. Instead of rendering thousands of DOM elements, we can use list virtualization. Libraries like React Window and React Virtualized only render the items that are visible on the screen. These can dramatically improve performance. Another important factor is how we structure state. If global state updates too frequently, many components may re-render unnecessarily. Good practices include keeping state close to where it's used, avoiding unnecessary global state, splitting state logically. This reduces the number of components affected by each update. In functional components, performance is closely related to how rendering works. Instead of class lifecycle methods, we use useEffect to handle side effects. Good practices include splitting effects by responsibility, adding correct dependencies, using cleanup functions. This helps prevent unnecessary work and keeps components stable. Now, here's a clean scenario answer. To optimize React performance, I focus on avoiding unnecessary re-renders. I use tools like React.memo, useMemo, and useCallback to memorize components, values, and functions. I also use lazy loading to load components only when needed, and list virtualization for large datasets. Additionally, structuring state properly and minimizing global updates helps keep React applications efficient. Alright, that's it for today. React performance optimization is a big topic, but these techniques cover the most common scenarios. If this video helped you, don't forget to like and subscribe. Thanks for watching, and I'll see you in the next one.